you're like many Americans, you throw your plastic water bottle into the blue bin with the expectation that it will be recycled. But that's not always the case. For decades, the United States and other wealthy countries have been dependent on China to buy and process almost half of the world's plastic waste. Now, stricter recycling standards in China mean it's cheaper for some US cities to simply send recyclables to the dump rather than pay a higher fee to process them. That's why a number of researchers and tech companies are working on making US recycling more efficient.
What we've done is develop this vision system that's able to learn from experience and is able to identify all these different bottles and cans despite them being smashed, folded, torn, dirty, every way they can kind of get gross inside your recycling bin, you name it, we can probably sort it out.
Our gripper has 2 fingers and it kind of reaches down and grasps. And on each finger, there's a strain sensor which measures how much the finger is changing length. And there's also a pressure sensor right at the grasping portion. Based on how these sensors are constructed, they also can tell metal objects because it changes with the electric field that it's measuring. So with all of those 3 combined, we came up with like a classification model to determine paper, plastic, and metal.
Before we get into how high-tech robots can help us recycle, it's important to understand why we started recycling in the first place and how that process is done today. During World War II, Americans were encouraged to collect and recycle paper, tin cans, rubber, and kitchen fat, which was used to make explosives, as part of salvage drives. But with the end of the war, people's interest in recycling faded and big landfills became the norm. It wasn't until about the early 1970s that a new awareness of environmental issues arose, with the celebration of the first Earth Day. In 1987, New Jersey implemented the nation's first mandatory recycling law. That same year, a garbage barge named Marlboro 4000 spent months on the ocean, looking for a place to dispose of its 3,000 pounds of garbage. The barge eventually returned to Brooklyn, where the trash was incinerated. The incident garnered lots of media attention and awoke Americans to the need for recycling. The US went from recycling 16% of its waste in 1990 to over 34% by 2015. Today, many of our recyclables still end up in the landfill, and at least part of the reason for that can be attributed to the way that our recycling industry works. That's because a large share of the recycling and waste management in the United States is handled by private companies, who are paid by cities. Often, these large waste management companies are in charge of both recycling and landfill.
The fact is that these companies make 60–70% profit from landfilling and incineration and hauling, whereas with recycling they make very little money, sometimes they lose money. So it's a direct conflict of interest to have these monopolized companies in charge of recycling.
Waste Management is the largest trash processing and recycling company in North America. While the company concedes that trash collection is its biggest profiter, Waste Management says it's committed to recycling.
For us, there's always more value in that material to be able to recycle it as opposed to putting it in the landfill. And even from an investor point of view, historically over the last, say, decade, the return on capital for the investments in recycling has been much better than the landfills. Landfills are very expensive to operate from a capital perspective, so we'd much rather see that material end up in the recycling facility turned into another renewable item. We've got over $1 billion invested in the recycling infrastructure in the United States. The last 2 years, we've invested over $100 million in recycling assets, even in very low commodity price conditions.
Here's how it works. When waste management companies enter into contracts with a city, they agree to split some of the profits that they get from selling their raw recycled materials. Say cardboard sells for $100 a ton. The company gets to keep 25% and the city gets 75%. But when the sale price of recycled cardboard falls, the company still has to give the city its 75% cut, and may actually lose money because the cost of processing the cardboard remains the same. So to recoup its losses, the waste management company has to raise the cost of recycling for cities. Some cities, who can't afford the higher prices, elect to just send everything to a landfill.
Waste Management has had to change the business model on recycling, where we now charge our inbound customers, whether that's a municipality or a commercial customer, a processing fee first. What this does is it ensures that our shareholders can make a good return on their investment and that we can continue to invest in the recycling infrastructure in the United States.
All of these different materials, whether they're paper or plastic or whatever, they actually have a lot of value. The trouble is that basically the cost of sorting, the challenges of getting these materials really separated out, erodes away a lot of that value.
This is where China came in.
The dependence upon China for our recyclables developed after around the year 2000, and that's because before then, virtually all cities were using dual stream recycling. With the inception of single stream recycling after, let's say, the year 2000, the quality of recycled materials in the United States deteriorated because of contamination.
Unlike dual stream recycling, single stream recycling allows residents to put all of their recyclables into one bin, instead of having to separate paper from plastic, metal, and glass. While single stream recycling is more convenient for residents and cheaper for waste management companies to collect, it deteriorates the quality of the recycled materials. Contamination in the context of recycling occurs when non-recyclable items are mixed with recyclable items, or when recyclable items are placed in the wrong bins. Items can also be contaminated if they have food stains, like, say, a greasy pizza box.
For about 15 years, this didn't matter because China was importing this material willy-nilly because they were desperate to get these raw materials into their industrial system. So they accepted our dirty, contaminated recyclables.
But that all ended in 2018 when China introduced a policy that banned most foreign recyclables in an effort to tackle the country's own environmental issues. China's national sword policy set a very strict contamination rate of 0.5%. The new standard made it very difficult for the U.S. to send its recyclables to China. During the first 4 months of 2017 to the same period last year, U.S. plastic scrap exports to China plummeted by 92%, while exports of alloys decreased by 53% and exports of paper decreased by 37%.
The impact of the Chinese market or Chinese import restrictions has driven the demand for greater and greater quality out of processing facilities, but it's also directed materials to new markets.
Other countries, including India, Thailand, and Malaysia, have stepped up to fill the void left by China's new policy. But even these countries are now pushing back on the massive amounts of recyclables ending up at their borders.
The result of all of this has been in the last year, the large processing systems had to add workers, and they had to add electronic equipment, sorting equipment, and this resulted in literally a doubling of the price of processing recyclables in the United States from about more than double. It was about $55 a ton. It's now about $120 a ton on the East Coast. Washington, D.C. is paying twice as much to recycle as they pay to get rid of waste.
According to data from the trade group National Waste and Recycling Association, the price of mixed paper fell from $32 per ton to $4.69 per ton from December 2017 to December 2018.
All of these different materials, whether they're paper or plastic or whatever, they actually have a lot of value. The trouble is that basically the cost of sorting, the challenges of getting these materials really separated out, erodes away a lot of that value. And so if you could use new technology to efficiently separate it, you kind of unlock the value of this material stream, and that helps boost the recycling industry. Increasing the quality of the material can improve the resale value, sometimes pretty significantly. It can be a 2x or 3x difference in some cases or more. The requirements have become quite strict, and so our technology helps them both control their sorting manpower and also produce material of higher quality than they're able to produce today.
This is why researchers and companies alike are working on high-tech solutions to tackle our recycling limitations. Leading the charge to increase the U.S. recycling rate is San Francisco, which diverts about 80% of its waste from landfill. The city has an exclusive partnership with waste management company Recology.
The ultimate goal here in San Francisco is to be the first city in the United States to reach zero waste. And the way we define zero waste in San Francisco is nothing to landfill and nothing to incineration.
San Francisco's Recycle Center is a 200,000 square foot facility that can process 40 to 45 tons of materials per hour. A lot of the sorting is already automated.
We use everything from very simple, like you started to say, human power to sort materials, but then we use things like a star screen. And a star screen is a series of concentric metal discs, and they spin around, and the paper actually floats up because it's lighter and the screens push the paper up while the containers fall down. We use magnets to capture metal, and then we also use what's called an eddy current magnet on the container line, and that repels aluminum. So it actually shoots the aluminum off of the conveyor belt and keeps that material separate. And then we go all the way to high-tech, state-of-the-art optical sorting machines that use light to determine the composition of the different plastic that's coming across the belt, and then uses ballistic air to shoot those materials into different containers.
The Sims Municipal Facility in Brooklyn is the primary processing facility for curbside recyclables collected in New York City. The site processes about 20,000 tons of materials per month, and like Recycle Center in San Francisco, is highly automated. But sorting is still not perfect.
One significant challenge or limitation today in the sorting equipment we use is optical sorters, which is how we separate plastics, cannot see black plastics. The near-infrared light cannot detect black plastic.
Another challenge for vision-based sorters is figuring out the material of objects that look really similar, like Starbucks cups, which can be paper or plastic.
The current recycling robots are all based on vision. So especially as more reusable plastic versions of normally paper things come about, it can be really easy to get confused between things.
Lily Chin is a second-year PhD student at MIT's Computer Science and Artificial Intelligence Laboratory in Boston. Through a collaboration with a team from Yale, Chin and her colleagues have developed a robot called Rocycle that uses tactile sensors to determine if an object is paper, metal, or plastic.
On each finger, there's a strain sensor which measures how much the finger is changing length, and there's also a pressure sensor right at the grasping portion. Based on how these sensors are constructed, they also can tell metal objects because it changes with the electric field that it's measuring. So with all of those three combined, we came up with like a classification model to determine paper, plastic, and metal.
MIT's system is still in its early days. Rocycle is 85% accurate when the materials are stationary, but only about 63% accurate when the recyclables are moving on a conveyor belt. Chin says her team plans to add cameras to the system to improve its performance.
Where I see the system really coming in is that before it gets to a recycling facility, if like on an apartment or a campus level, we can sort of keep the convenience of single stream recycling, but having the robot pre-sort it into multi-stream, then we can have lower contamination levels, but also have the convenience so people will continue recycling.
AMP Robotics is taking a bit of a different approach.
At AMP Robotics, what we're doing is developing artificial intelligence and robotic solutions to some of the primary challenges that the recycling industry faces today. These facilities have major problems around both the sorting of all these different commodities and also achieving high purities for the materials that they sort out and then sell. One of these big challenges in the recycling industry, the issue with basically the changing material stream. So even beyond introducing new packaging, consumer habits have changed quite a bit over the last several decades. A lot of recycling facilities were built around the idea that you'd have a lot of newspaper coming into them. Now that's replaced with a lot of cardboard, so think of Amazon boxes and stuff like that. Other issues around packaging where they might have multiple layers of plastic or multiple layers of metals inside of them, those can also be difficult for these facilities to manage. What's cool about the artificial intelligence technology is that you can teach it to identify pretty much anything that a person can learn to identify. So what this technology provides is a lot of flexibility for the facilities, and they can process material in the way they want to, and then the ability to adapt over time. Since these robots are really a platform that improve and gain new capabilities over time, they learn about these new materials, and then you can assign them to sort those materials out.
In addition to sorting municipal waste, AMP Robotics software can also handle electronic waste and construction waste. The company has already installed its software on over 12 robots in recycling facilities in North America. Finland-based Zen Robotics and Oregon-based Bulk Handling Systems are also making AI recycling robots. While recycling facilities have been able to find many domestic markets for their materials, they're still investing in new technology for the future.
We just did an $11 million upgrade here after 16 years of running this plant, and we're putting another $3 million in this year in the high-tech optical sorters and robotics.
In late 2017, we installed our first robot in a recycling facility. Now we have about 4 robots that we've been testing, and by the end of 2019, we'll have 8 robotics in our recycling facilities.
Despite the initial stress on the recycling industry, Seldman says China's regulation is good for the US in the long run.
The trend is very clear that new companies, new processes in the United States are within a few years going to take the place of all the materials that are going to China. This does not mean that Americans will not be sending good, clean raw materials around the world to companies placed in other continents. That will continue, but it will be a better system because what's coming out of the United States is much cleaner.
But perhaps the best solution to our recycling problem is just to make sure that recycling remains the third R. Reduce and reuse, so that you don't have to recycle.